All right. Hey everyone, I'm David Room. I was thinking about what to stream tonight since we've been doing a lot with the orbital mechanics, gravity, planets, things like that. And I wasn't exactly sure what to do next, but then I realized there's a couple obvious next things to do that will kind of let us keep momentum on this, will be a good excuse to make some things that we've sort of implemented, um, kind of a hard coded version of an excuse to make those things more rigorous, and it should be kind of hilarious to try on stream because it'll probably just end in tears. But what I'd like to try to do today is actually implement the sun and moons of planets in the system that we're building with celestial bodies. So I was thinking about kind of having a um, special functionality for the sun where I could specify the angular diameter and the direction of the sun, and then it would size things like right. But I mean, I think distant planets works pretty well, so we might as well just implement the sun the same way. So that would be funny. And then in my setting, there's going to be different conflicts that take place around moons of planets. So in that case, we're going to want to have both the moon and the parent planet in the skybox. So that's kind of an easy thing, uh, easy and obvious thing to do. And if we do those things, we should be able to model the orbits of the different bodies around those things, and that would be a good excuse to add some functionality into our orbit sphere to select different things we want to view. So I'm not sure how far we're going to get. It's kind of late here, but I wanted to work on this. I wanted to go live and see how everybody else is doing. And and I think this should be pretty visually interesting. I think we should be able to make some progress pretty quick with it. And that's the kind of fun thing about this, right? Is like once you get these physics systems um, in place, then you can start adding complexity and additional stuff, and it just should hypothetically, knock on wood, kind of work. So let's just get into it. I'm gonna listen to some driving music again tonight. So we're gonna go back to plasma here, and yeah, let's get to it. So um, let's actually do um, a moon first, because that's going to require a little bit more fiddling around at the beginning, I think. But yeah, let's do it. So um, let me see if it makes sense to do this in a different mission here. Why don't we actually just keep working in mission 4, and let me just check something here quick off screen. Okay, yeah, we'll just keep working in mission 4, and if we run into issues, we can always revert. That's the great thing about source control. And yeah, okay, so here's what we're going to do. We're going to make a moon. It'll just be a sphere. We're going to make the moon Umbriel, which is an important moon in my setting. And then we're going to put it in orbit, and then we're going to adjust our things so that we've got our position being in orbit of Umbriel, and Umbriel is orbiting Uranus, and we should be able to see all that stuff. So yeah, let's do it. Oh, and yeah, we'll have to do some stuff with the skybox too, where we add multiple planets. That might be an interesting challenge to work through, but I think we can do it. I think this is a good goal. So here we go. Let's add a new parts set here in our model creation script called we'll call it bodies. And we'll make it yet another planets thing. So let's see here. So this will be from projects. And stars is, I think, a module in oh, interesting. Actually have a module called stars. Why don't we just stars import bodies? That's fine. Maybe we can switch these things around later. The names aren't too important. So, and I'll show you kind of what I'm thinking of here. So, bodies is going to be so here I was talking the other day about my own like mesh processing functionality. It's been a while since I've done a modeling stream, but you'll see some of that here, even though it's going to be really simple. So and then for now, this is just going to all be low detail. So no WODs. And actually, this will be actually a part. I don't know if I usually do this. But the idea here is like, is that this is going to be a UV sphere, but we're going to give it some random vertex colors. It's been a while since I've done this stuff, so I've got a this P3D. So it's going to be interesting, kind of reminding myself how this works. P3D dot icosphere, and I think it's going to be about 8. And then all of these bodies have radius 1, so things scale properly. And then, let's see here. I had some stuff that let me view parts with game materials described on them. And here, we're not going to use the materials, but we are going to use a vertex colors property. So we want vertex colors to be something, and our part is going to be a part where we have just the sphere, or let's see, the model is the sphere, and vertex colors is going to be our vertex colors, and then we should be able to view it. So with game materials, GM view parts, true. And we'll just quit here, and we'll actually bring this up to the top. Just call this puppies. Okay, and now let's define vertex color. So yes, so Doug Wise says, is this building out the moon Umbriel? Yes. And we're just doing a very simple procedural thing here first, just to test. But I feel like I'm kind of establishing my attitude on this is like good enough. I want things to be somewhat realistic, so we're going to try to give it a somewhat realistic albedo for the vertex colors here. So let's see here. So mu dot, let's see here. Mu. I think I've got a mu dot vertex colors where I repeat. Yeah, I can repeat that, but I actually want to do something a little bit more interesting here. So I want to actually this will be fine because I can do two colors and then interpolate between them. So we'll do color A. I always forget how to tile things like right, so this is a little bit inefficient, but whatever. And let me just check something. Vertex colors. I'm pretty sure that these are going to be all. Yeah, these are going to be all one based. Yeah, okay. So now this is where we look up the albedo of Umbriel. In RGB. Yeah, that makes sense. Actually, no, I do have color types from modeling.types import RGBA. RGBA, what was it, 0.18 and then 0.12 for the blue. Yeah, that makes sense. So sort of a bluish gray color. Oops, and alpha is going to be 1, of course. And sphere dot hertz. What we're actually do. Albedo, what's this? So this will hopefully give it a little bit of interest. And let's just see. Umbriel's got that icy spot at the, or Wanda, the crater. I don't know if Wanda actually has color. Bring a bright material. Okay, so maybe, hey, let's continue this little conversation with Gemini. What's the albedo of Wanda? Yeah, 0.49 or 0.45. If you're bluer, okay, so yeah, just a little bit stronger blue, so that makes sense. We could add one to in here as a stretch goal if we get the rest of this working, but who knows? Like I said, I think this might all end in tears. Okay, so we're gonna do n equals np dot let's see, what is it? np dot random step. Random state. Random state takes a seed, of course, and I think it's random that we want, right? Whoops. Random. Yeah. So we're just going to generate some slightly varying vertex colors here. So random of the length of sphere.verts. And yeah, this is just a lerp. Actually, lerp. This is, I don't have this in general utilities, that's fine. But it's going to be, all right, so that's going to give us our vertex colors, and this is complaining because why not? Types vertex colors. Get it to shut up. Vertex colors, and let's just see if this works. Okay, it's going to want a lot in mode anyway. Let's see here. Where's those mode constants? Mode print from projects. Shared. It's been a while since I've looked at this. Assert lot equals 0. Equals shared. So we're not 3D printing the sphere. So, okay. Oh, wrong function. This can actually just go here. And let's just clean this up. I think we're on the right track here. All right, well, that's way too many subdivisions, first of all. And so something like that. And we've got to add a add an extra dimension there. Invalid syntax. How do we do that? I always forget. It's like one of those things that you just don't do enough. Transform. See, transform birds. Maybe it was rotate back. Yeah, so I think actually I just gotta go. I just have to do this. It's kind of embarrassing, but I didn't remember this offhand, but whatever. Okay. As long as we're doing this. Something like this. Oh. That's right. Okay. This is props. Face colors. Interesting. What is going on here? So vertex colors is not none. That has to be a typo. Yeah, okay, there we go. And we can see right off the bat that, oh yeah, that should be 1.1. There we go. Yeah, something like that. And that's actually still a lot of subdivisions. So let's try 3. Yeah, okay. That's looking more like I was picturing it. And does this kind of look like let's see here. Smooth. Oh, I need to add an auto smooth angle. Auto. Get a better idea of what it'll actually look like here. Auto smoothing does not support vertex colors. How can that be? Auto smoothing does not. Okay, well, that's all right. We'll solve that problem later. But I think this basically is what we want. So we'll return that part. And run it. Okay. So now let's just test. We'll just make a test here where we'll treat Umbriel just as like its own thing, like we've done with Uranus and the moon and Venus and stuff like that. So this will be a nice one to test with because it's going to be, I believe it's even smaller than the moon. Let's see here. Simple English. One 1.2885 and 2885 times 10 to the 21. Kilograms, and radius is equals kilometers. So I always do this conversion wrong somehow. Oh, that was the diameter. Oh yeah, there. Yeah, the radius is that. What's that? 10 to the 6th. Yeah. So it's like a quarter of the diameter of the moon. Does that look right? Yeah. Or half, not a quarter. A half the radius. Somewhere in between. It's 1, 2, 3, 4, 5. Yeah, okay. Yeah, the size comparisons with the moon made it seem pretty small, Doug Wise says. Yeah. And we're going to try to do this as a part. Hopefully, I don't spend a long time getting this working. If I have trouble with it, we'll just make it yeah, no, this should be fine because model info should pick up if it's a part. Color none. Skybox real. I might have to double check this. I think actually, yeah, I think that's what we want. Okay, so let's just see. This is one of my favorite White Bat songs. It's called Revolt. Okay, so in mission 4, which for some reason we don't have loaded. Okay, mission 4. Let's just swap this out with Unreal. And let's see if it works. Nope. Let's see here. Real info. File name. That's looking for an egg. Oh, I know what I did wrong. It is part. It is part colon bodies slash. Nope. All right. Multi. Is it 2 colons? File path. Model cache. Dir path. Slash egg. Slash. Oh, did I? Let me just check something. Did I screw something up here? No. Why is it? Where's my logic for if it starts with part? Might have to... Let me just try a couple more things here. And then... Let's see here. Let's see here. What is this expecting? This is expecting a file path. And let's see here. It is expecting... Let's see here. How are we getting this? Dir path. And the file name is this. And then enter path. Oh, does it just not want the part thing? No, that's not it either. Okay. Turn name. This name. Let's just print some of this out here. Path. I want to work this out because I don't want to have to be doing like these separate. Oh, okay. Okay, here we go. Part. Yeah, but see, this is the right logic. Is it? What is going on here? Something weird is going on here. Do I have to add .egg to the end? That would be funny. Okay, I'm gonna spend about 1 more minute on this, and we're gonna do it a different way. I just don't get it. So, okay. Oh, 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 oh. And I'm close. I've almost got this. Umbrella. Models. But I can't find what egg multi, but egg multi enable. But why are we not adding? But why is this not getting .egg on it? That's what I can't figure out. Oh wait, no, we're okay. We're getting there, but we have a key error because our complete. There's just something I'm missing here about the right combination of things. I think it's yeah. Okay. We will not load this from egg. Let's see here. We've got bodies.egg and bodies.pickle. Let's actually so let me just see something. Let's, wait just a second. Model cart : Oh, that's what's going on here. Okay. That is what is going on here. So if planet model file name, if not planet starts with part, then we got to do this abs path thing. I should have looked closer at this. Because this load bullet models is definitely how I load the bullet models. Okay, so now if we do part bodies Umbriel, it should work. See here. Model info. Part. It just is like it's not. There's something here that's not gelling. Okay, we will do this differently. We'll figure this out later. So trying to figure out where this planet's slash gets added on here. It's part of the name somehow. Oh, that's it. Okay. So I just have, yeah, planets. Oops. Okay, and if we should be there. Okay, let's load it up now. From egg. Let's see here. Okay, yep, there it is. Now, okay. So that was a long way around, but we've got it now. So now, let's try loading multiple things. So yeah, let's just let's make this real planet skybox take multiple planets. What could go wrong, right? So we've got we'll have this be a string radius name. Okay, so and the funny thing here is we're gonna replace the sun with one of these two, but for now I think this is just gonna be for loop. Right, and then we've got the sun on the planet and the ambient light. We'll want to set these up first, actually. And then set the light. And actually, here, we should do this by name. So, actually, we should have a name, file name, position, and radius. Index, planet name. And then the name will be this, so we can find it. And then name. Take planet. We want to find it by name. We can do a nicer way of handling this a little later. This gets just a little bit more complex. We're going to want to have some nice data structures for handling this stuff, but for now, we'll just get things up and running with this as it is. Okay, so now when we do the skybox, this actually will get a little bit neater here. So planets equals name and file name. Ooh. No. I wonder if we broke something here in how we're loading. I wonder if, let me just try something here. Yeah. Okay, so it's something to do with the name. Breaking things. So let's try I wonder if yeah, so something is going on here. Let me see where I'm calling update planet. Planet name, body name. I'm just gonna try a couple different things here quick. Well, let me just review this logic, but we might be sort of being foiled by some things that I don't understand here when it comes to panda. The issue is, it's like, it's very strange that the let's see here. What happens if I do this? Does the lighting work? Because see, I don't understand why this is related. There's something strange going on here. Yeah, so see, we have the... Oh, there's something interesting. Is that rendering transparent? There's some weird artifacts going on there too. That's very strange. Let me see. Let me just test something. I might have uncovered some other bugs here. Let's see here. Oh. That's a problem here too. Let's fix that. Just some aspect of the wiring here that is not hooking up like right when it comes to those vertex colors. And I'm not sure what's going on. It doesn't seem like the name here should have anything to do with the other aspects of this. And planet.name here should be the same as body.name later. So yeah, it's very strange. Let's go after this a little bit more here. And this is obviously working because if it was the wrong name here, we crash. Okay, let's see if we have... Oh, I know what's going on. It is... It's the order that we're getting children from the skybox, I think. Get child. Because we were expecting the stars. Yeah, that's what's going on. I'm starting to get bit by not having to some planet. Let me just take a look at this again. So it could be that the Okay, let's just see if we have this. I'm at a loss for what's going on here, so this might be yep, so that has the same problem. And that's weird. It has something to do. Is there something else that's looking for a... These are the old skyboxes. Planet skyboxes. Just trying to think if there's something else that depends on the planet being named planet, but and this is the old planet skybox, but this is the new one. Something just is depending on that in a way that I just can't seem to figure out. let's see. This should fail instantly, right? But like, what if we just say if sure. Like, is it something that's happening in here that's getting rid of those vertex colors? Update planet. Let's see. We just call it planet here. So we update it just once. So it's something. Now, if we call it planet name, okay, let's try this. Something like this. There's just something about man, that is weird. That is really weird. Does it work with some other constant name? So the problem is, it's like we're naming these objects in the scene graph and like we're trying to find them, but there's something strange or special about the planet just in the skybox having the name planet. And I'm trying to figure out why. Is it a shader thing? Am I not shader? Set shaders. Game.spacelighting.skybox.np. Is there like a... That's probably it. Oh, that's... there we go. There it is. There's the problem. So... yeah, okay. So that explains why planet wasn't turning up the answer. So I think we can do something like... I think we can use more wildcards, right? So let's say... let's see, yeah, so it's gonna be the scene graph, searching the scene graph. Let's see here. Yeah, the name that begins with that. So what we want to do is we want to have planet be a prefix, and this is just like, you know, we don't want to do this long term, but for now. Don't do this. For planet np and let's find all matches. Planet star. And then skybox real, we're gonna say set name planet plus planet name. Update planet, planet plus planet name, and then update planet. I'm going to be very surprised if this doesn't work now. Okay. Whew. And check here. Okay. Whew. All right. Let's fix this up. Well, okay, so at this point it's getting late, but I think we can get at least Umbriel and Uranus in there. I think that's a good thing to check, or try to get to. So yeah, let's do that. So let's do this. So we'll say planet equals Uranus, moon equals Umbriel, and we'll do some stuff. We'll set up some different logic here. So use moon equals true. Whoops. Okay. If not use moon, we'll do basically what we're doing now. And our planets for skybox equals this. Okay. Otherwise, we will okay, so it's got a more or less circular orbit. Okay, so is 266.6. Eighth. See. And then we'll say orbit radius, we'll do, again, planet.info, but we'll do moon. Okay, so now we have to find a couple of different things. So let's see here. Where am I finding that velocity? Yeah, orbital velocity. So this is, again, if not use moon. Okay, so let's just lay out everything in a let's see here. Planet position default is just this. So let's actually do this. So so this will be where the moon goes, but then we'll set off Uranus farther back in a position that is like offset by certain angles, so we can see both of them. So offset is going to be vec3d of, let's see, normalized, vec3d of, it's going to be like -1, 1, 0 dot normalized times let's see here. Oh wait, no. And let's just call this, actually, we'll just do all of this as offsets. Umbriel offset is this, and then the Uranus offset is that, and we will say moon.pos equals Umbriel offset, and Uranus offset equals Umbriel offset plus Uranus offset. Oops. Planet.pos. Okay. And then we've got to calculate the orbital velocities too. So this takes care of the positions. Now we've got to do the orbital velocities. So okay, so this is where things get interesting. So let's see here. vel umbrial orbit equals orbits dot orbital velocity of planet, or let's see, moon dot info dot mass. Let's see, umbrial orbit radius and vel Uranus orbit equals orbit velocity planet dot info dot mass. What do I call it? Orbit radius. Orbit radius. Now, let's instead of kind of hard coding this with unit Y, let's actually figure out what this should be. And it's going to be the cross product of is that right? It's going to be the cross product of Z with the actual, like, the normalized position, right? So, so the VPOS for the umbrial orbit is going to be vec3 dot unit z dot cross crossed with vec3 of moon dot pause minus planet dot pause times pause. Okay, and then orbit is going to be there's no way we're going to actually get this working tonight. There's some other things that I forgot that we have to do here. It's just going to be, oh wait, no, this is going to be this is going to be this is just going to be unit y times v pause. That will be the same. Unit y v pause. But this guy is going to be what we want here. So okay. So and let's put this crap up in here. And then we'll add these two velocities together. And then the reference entity is going to be the space station. And then okay, now we have to do a couple other things. So we got to make sure that in our physics that we're actually updating the positions of celestial. We're applying forces to celestial bodies and updating the positions of celestial bodies, which might be a little bit too much for tonight. Let's see here. Forces. Apply forces. We might be able to fake it here. Let's see here. So let's see here, forces. And I think when I'm calculating forces, let's see here, gravity. I should be calculating gravity from multiple celestial bodies. So that's good. And then when we do the physics update, we'll just say this. So if this is really hacky, but update node paths. Let's see here. So if there's more than one celestial body, we'll exert force from the first celestial body onto the second one, and apply it. So force equals, let's see here, body A there's no way this is gonna work right now, but we're almost there. We're almost there. Okay, and then force equals actually can't even do, I'm not even gonna be able to use this. Let's see here. Opposite group. Somehow I had pictured that this was all ready to go in a lot more complete way than I pictured. So, but let's just repeat this. So basically rvec equals let's see, A B dot pause squared. And let's see, so acceleration, F equals ma, so acceleration is force divided by mass. So accel equals force divided by body B dot mass. Why is this being flagged? Unresolved. Oh, body A dot info. It is info there. And a.info.mass, and we'll just do the little update right here, I guess. So body b dot pause plus equals excel times constant stat ticks per let's see, divided by constant ticks per second. Is that it? Let me just check my normal. Oh, no, it's not the pause. Celestial bodies don't have velocity yet. Oh, that's actually, let's see here. Yeah, okay. Let's just go crazy with this. Oh no, they do have velocity. And then b dot pause plus b pause times. Yeah, I think we'll use that instead. So constant stop tick time. Yeah, and then as we go on, we'll want to see. Okay, nice. So Habib Peel says, "Hey, what are you making?" So I'm working on a space combat game, and I am working on adding some new functionality related to actual gravitational forces and planets and orbits and stuff like that. So I'm kind of hacking in multiple celestial bodies today. For some reason, I guess I thought this was going to be way easier. I've got things where I can basically, I can have like one celestial body, like a planet or something, and I thought it would be interesting to try to get like a moon orbiting a planet going. So, um, and then in order to be able to see this, um, in order to be able to see this, we're actually going to have to see in the orbits view a celestial body relative to another one. And that actually, the more I think about it, is not going to be super easy to hack in tonight. But we should be able to see this running. And this is actually sort of a good test because it's going to test whether the orbits UI stuff is properly understanding relative velocities, right? Which it should be. We should never just be assuming that the body is not moving. But okay, so Habib Peel says, where are you from? So I'm from the United States, and I'm from a state called Wisconsin, in the, you might say, Midwest, central, kind of north central part of the United States. Okay. So I don't think we're really going to be able to see the orbit of the moon around the planet, but this should be a check to see if the system is stable and if our orbits UI works. So let's see. So yeah, so Habib Peel says, "So you're implementing physics in the game?" Yes. I have part of why I'm making this game is just from my own understanding of physics and how you might implement a physics engine. So I am kind of implementing my own physics integration, for better or for worse. And it's kind of fun to see things come together. So let's fire this up and see if it actually works. And I'm gonna double check this. So the orbits UI config that we're going to be visualizing again. So when we look at the orbits visualizer, we should see ourselves the orbit around Umbriel. When we start this up, we should see Uranus in the background. Oh, I know what I've got to do. I've got to update planet for each of the celestial bodies instead of just one. Okay, so yeah, so now we're going to do this for body in game.celestial bodies. planet. Yeah, okay. Alright. We've almost certainly forgotten a few things, but let's see. Okay, planets for Skybox, reference before assignment. Oh yeah, we've got to set this up here. So if we're not using the moon, it's just the planet. If we are using the moon, it's going to be the same thing, but with the moon too. Oh, okay. Yep. And this we've got to convert back to double precision. Actually, this I think what we want. Whew. Whew. Our velocity is out of control. Okay. So we did something wrong in our initial velocities, I think. So let's see, planet info. 8. Let's see here. Planet. I don't think that should be the problem. Let's see here. At first glance, that doesn't look completely out of oh, there's our problem, or at least part of the problem. This guy needs to be normalized. Derp. There we go. Oh. Okay. Now. Oh, look at that. Okay, so we're not seeing a orbit. So that means that we're in some kind of degenerate situation here, according to the orbital elements calculation. But things are sort of lined up correctly. Let's bring Uranus a little bit closer. Let's see here. Habib Peel says, looking good. Thanks. Let's see here. Wait. Let's see here. A bit radius. Oh wait, no. We don't want to bring Umbriel closer because that's where it actually is. Let's make this a little bit smaller. Now, just so we're a little closer here, but it looks like yeah, it's like we're on some kind of like escape trajectory, so we're not calculating we don't have our velocity, like we're moving pretty fast relative to Umbriel. Okay, so Habib Peel says, actually, I've been thinking about getting a laptop or Mac. Which one do you suggest as a programmer? I'm doing my bachelor and my major is applied computer science. Cool. Okay, so I'm right now I'm using a MacBook Pro to do this work, but for my personal computers, I have both this MacBook Pro and I have a Linux desktop that I use. Both are really good. I would, well, both Mac and Linux are good. I think what matters is getting good hardware, like getting the best hardware that you can afford. So you have something that will last. I think both Mac and Linux are great for developing. I probably, at this day and age, would not recommend getting a Windows laptop. I mean, you could get a Windows laptop or Windows computer, but then put Linux on it. And it doesn't have to be some obscure distribution. I use Ubuntu. I probably prefer the user experience of Ubuntu a little bit, compared, like, a little bit more than Mac OS. There's some quirks of Mac OS, but both are great. I think if you're getting a laptop, I would pretty strongly recommend getting a MacBook. I think just the quality of the hardware, the ARM CPU, like I've had my MacBook since 2023, and it's just like the best computer I've ever had, and it's been really good. So yeah. That being said, just about anything will work. I mean, a lot of my projects I could be doing on a, like a ThinkPad that I got off eBay for $400 or something, So you don't necessarily need to go crazy with computer hardware to have something that works. But between yeah, between Mac or PC, I mean, I would just say avoid Windows. Think about using Linux, especially if you're studying computer science, on a PC. Macs are great too. And one other thing I want to note is, like, for me, most of the software that I use every day can run on either Mac or Linux. Could probably even run on Windows, but you're kind of covered between Mac and Linux. So, oh, here's a problem. Okay. Laptop I'm thinking. So Habib Peel says the laptop I'm thinking about is ROG Zephyrus G16. You could say that's the top of the line in laptop. Yeah, I mean, probably if you are thinking about getting a non-Mac laptop, I wouldn't cheap out on it. Get something high quality. Um, oh, nice. Okay, so Maximus the Gamer says, how did you make this? What library? So I'm using a engine called Panda 3D. It's a very old game engine that Disney developed back in the day, actually with Carnegie Mellon University. But it kind of suits the style of my game, which is like a more old-fashioned kind of retro-looking game. Okay, we're getting really close here. I think I just have screwed up this offset somehow. So, um, let's see here. So we're sending Umbriel back this way. And then Uranus is going to be offset from Umbriel that way. And I think that's what we're seeing, right? We're seeing the right directions of things. Yeah. But our velocity is just too fast relative to Umbriel. So maybe it's just... Oh, I know what it is. I didn't give Umbriel any initial velocity. So... when I calculate the velocity of the Uranus orbit, I need to give that to Umbriel. Geez, okay, so moon dot vpos equals vpos. Okay. There it is. Now, do we have... There we go. Okay. Now, maybe some weirdness here. We've got a really strange looking trajectory for the station, which does not look right at all. So I'm not sure what's up with that. Station. But we're getting close. I mean, yeah, like that's strange. Something is not right there. It's probably we've just got a sign swapped around here on one of these. So let's just double check this. Oh yeah, this is not going to be unit. Let's see. It is, yeah, it is going to be unit Y. And then minus planet pause. Let's see. End minus start. Is that going to be the direction? Let's see. Right hand rule. also possible that we have some kind of oh, now see my orbits. My orbits HUD is showing Uranus as the reference point for the orbit. So I wonder if that's or my orbit's MFD. Let's see here. Let's see. It's MFD. Celestial bodies. Let's see here. So if just for now, if just doing some hacks in here. Eventually we'd want ways to swap these around. Yeah. I just don't know why. And this being on the opposite side, that doesn't make sense. Something is goofy there. We're not, there's like a reference point or something that isn't right. Let's see. Just update. There's only one spot where we're updating it here. We send the whole thing in, actually. Where do we build that config? We're doing this correctly where we're incorporating the body's velocity. Yeah, so we got two problems here. Basically, we've got an incorrect orbit for the station. I could actually see... and then we have something wrong with the... Let me just see what happens if we run this forward faster. Yeah, there's definitely like a sign issue here because you can see the position of the station is correct. But yeah, it's strange. We're subtracting off body pause there too. Yeah, and this is right because the force should be directed from... from body A to body B. And then here's the integration. Let's just read this over once and then we might have to call it a night and come back to this, but I think we're really close. I think we got the relative positions of things right. Just maybe not the velocities. So if we're using the moon, I think we got this right because this looks right. And we're offsetting it this way, and we're offsetting Uranus that way, and that looks right. We're setting those. And then, let's see here. So we started with the moon directly off to this side, so our velocity is going to be like forward Uh, is this backwards somehow? Oh, let's see here. End minus start. No, that's right. Yeah, well, I think we're gonna have to call it a night here. We didn't quite get as far as I wanted, but we definitely made some headway with the sort of multiple celestial body simulation that I'm thinking about. A little bit hacky, but I think we got the positions right at least. There's just something a little fishy about the this orbits view. Some things that are going on there that I'm not really sure what's happening. Oh, let's see here. Wait, no. The station. Yeah, the positions aren't going to change. I'm setting the positions of the planets kind of relative to my play area. So that stuff should be fine. Yeah. This something is strange, like, so me the player and the station having these same velocities should not result in those kind of like weird flipped orbits. So something is not right. Oh, here we go. Here we go. This is wrong. This is backwards. Okay, now we're getting somewhere. This is backwards. So, yeah. Okay. So, the velocity of our... Yeah. The velocity of our orbit around Umbriel is this. And... yeah. I think this is right? Because this is the one that we're making up, right? This is the arbitrary one. And this is the non-arbitrary one. There we go. There we go. Okay. And the Umbriel is so small that our even just our accelerating into the station really breaks our orbit. But yeah. So Now, we don't have a way to visualize the orbit of Umbriel around Uranus, but it is actually moving. Um, if we ran the the um, the time forward, we might actually even see it rotate. That might be hoping for a little bit too much tonight. But let's just see. We can always hope. Yes, Doug. Doug says the urge to close on a successful troubleshoot is strong. Okay, so um I don't know how to pronounce her name. I'm going to mangle it, but Madad 7119 says, "Hi man, first time viewer here. Appreciate that you code out here in the public. Helps me as a newbie / non-coder to gauge on how to approach on solving problems. Keep thinking out loud." Oh, thanks. I appreciate it. That's kind of why I do this. Is it's fun to. Okay, Adam. Nice. Nice to meet you, Adam. Yeah, it's fun to try to do things kind of in front of other people. Sometimes it sort of keeps me on my toes. And another reason I like doing this is I used to do a lot of pair programming in my day job. And unfortunately, I don't get to do that too much anymore. And there's something kind of exciting and nice about having to program in front of other people. So now let's just see here. Okay, so we do see Umbriel moving here. But whoops, we're moving relative to it. Oh, the combat has caught up with us here. But yeah, so I'm not seeing, well, hard to say. I need to do some research about what the periods of these orbits are too. So let's see here. Orbit of yeah, it's like the period's like 4 days, so it's probably too long to even see too much motion there. But at any rate, we do see some. We're seeing at least where I hope to get to, where we have orbits here, and the fact that yeah, the fact that we seem to be tracking here says that I think the velocity of the moon is being calculated somewhat correctly. So Adam says, do you build game for your job or do you do software programming too? So I'm not a game developer by trade. This is kind of like a fun project. I work more in like machine learning and computer vision. It's kind of like software research engineer. So I use a lot of Python in my day job. And that's why I'm using Python for this project, is I like the Python programming language a lot. But it's not my like game development is not my career. Well, um, let me just look at something just quick. It is very late and I should go to bed, but I just want to look at something. So I'm just wondering, how hard would it be a lot of this stuff probably. Yeah, this is all set up for entities. So eventually what I'd like to do is I'd like to see um, I'd like to see yeah, I'd like to be able to toggle some things in this orbit sphere and be able to see, you know, the relationship between Umbriel and Uranus and stuff like that. Start bridging the gap between, you know, small areas and large areas in the game world. I think that would be really cool. But for now, this is pretty exciting to have like to have more than one celestial body. To start thinking about how we're handling these things. It's definitely hacked in for now, but it's cool to see, man. It's cool to see those two planets as well. And the sun next. We'll get the sun in there as a celestial body as well, and that's gonna be neat when we do that. All right. Well, thanks everyone for watching and hanging out. We made some good progress today, and I think I've got some ideas for next steps too. So if this is interesting and you want to see more, I mean, definitely subscribe. I've got a lot of videos, live streams from the past where I'm working on this project, getting into some pretty cool stuff now, I think. But yeah, definitely subscribe, check out other videos, and I'd love to see you in the chat again. And I'd love to hear about your projects and what you're working on. So, yeah, thanks, Doug, Adam, Maximus the Gamer, Habib Peel. Yeah, thanks everyone for hanging out. Catch you later.